Welcome to our podcast on architectural geometry, everyone. I'm Amira, and joining me today is my colleague Kai. We'll be discussing an intriguing aspect of architectural design, completing roofs using two triangles.
Thanks, Amira. It's great to be here. This topic is particularly fascinating because it combines practical construction techniques with fundamental geometric principles. Shall we dive right in?
Absolutely, Kai. Let's start by explaining why triangles are so crucial in roof design. Triangles are inherently stable shapes, providing structural integrity that's essential for load-bearing elements like roofs. Can you elaborate on this?
Certainly. The triangle's stability comes from its rigidity. Unlike rectangles or other polygons, a triangle cannot be deformed without changing the length of its sides. This property, known as triangulation, is why triangles are ubiquitous in engineering and architecture.
Excellent point. Now, when we talk about completing a roof using two triangles, we're often referring to a gable roof design. Could you describe what a gable roof is and how it incorporates these two triangles?
Of course. A gable roof is characterized by two sloping sides that come together at a ridge, forming a triangle on each end. These triangular ends are called gables. The two triangles we're discussing are these gable ends, which effectively complete the roof structure.
That's a great explanation, Kai. It's worth noting that the angle of these triangles can vary depending on factors like climate and architectural style. In regions with heavy snowfall, for instance, steeper triangles are often used to prevent snow accumulation.
Absolutely right, Amira. The pitch of the roof, which determines the steepness of these triangles, is a critical consideration. A steeper pitch not only sheds snow and rain more effectively, but also creates more usable space in the attic or loft area.
Interesting. Now let's delve into the geometry a bit. When we're designing these triangular gable ends, what mathematical principles come into play?
Great question. We're primarily dealing with right triangles here. The base of the triangle is the width of the building, while the height is determined by the roof pitch. The Pythagorean theorem, a squared plus b squared equals c squared, is crucial for calculating the length of the rafters, which form the hypotenuse of our triangle.
That's fascinating, Kai. It's a perfect example of how fundamental mathematical concepts directly apply to real-world construction. Are there any other geometric considerations when designing these triangular roof elements?
Absolutely. We also need to consider the concept of congruence. Ideally, the two triangles forming the gable ends should be congruent, that is, identical in shape and size. This ensures symmetry and structural balance in the roof design.
Excellent point. Now let's talk about the actual process of completing the roof using these triangles. What are the key steps involved?
The process typically involves first constructing the roof trusses, which form the triangular shape. These trusses are then erected at each end of the building. The space between is filled with rafters that run from the ridge beam to the top plate of the walls. Finally, sheathing is applied over this framework to complete the roof structure.
That's a great overview, Kai. It's clear that while the concept of using two triangles to complete a roof might seem simple, there's a lot of engineering and geometric precision involved. Are there any modern innovations or technologies that are changing how we approach this traditional design?
Indeed, there are, Amira. Computer-aided design, CAD software, has revolutionized the process, allowing for precise calculations and 3D modeling of roof structures. This technology enables architects and engineers to optimize the design for factors like load distribution, material efficiency, and even energy performance.
That's fascinating. It seems like even with these technological advancements, the fundamental principle of using triangular forms remains constant. As we wrap up, Kai, what would you say is the most important takeaway for our listeners about completing roofs using two triangles?
I'd say the key takeaway is that this method beautifully demonstrates the intersection of practical architecture and theoretical mathematics. The use of triangles in roof design is a testament to the enduring relevance of geometric principles in creating stable, functional, and aesthetically pleasing structures.
Wonderfully put, Kai. Thank you for sharing your insights on this topic. To our listeners, we hope this discussion has given you a new appreciation for the geometry behind the roofs over our heads. Until next time, this is Amira
and Kai, signing off. Thank you for listening.